Okay, so here on lesson 4, we're supposed to verify that the mean value theorem does or does not apply to this polynomial on the interval from -1 to 1. So if you remember, the mean value theorem says that in this interval -1 to 1, there's a value of c such that f prime of c is equal to the slope within the interval. So this would be f of 1 minus f of -1 all over 1 minus -1. Alright, so that's what we're supposed to verify, is that either does or does not apply on this interval. So the first thing we need is the derivative of f, and then we're also going to need the slope of f. So we're going to need f of 1 and f of -1. So I'm going to actually start with that. So I'm going to start with the slope. And so if we plug in, let's see, if we do f of 1 here, plugging in 1 is pretty easy because we get 1 plus 2 is 3 plus 4 is 7, and 7 minus 12 is -5, minus f of -1. So we got to be a little more careful. This is going to be -1, this is going to be -2, this is going to be -4, and -12. So that's -3, -7, -19. So we're going to subtract -19 all over 1 minus a -1, which is 2, and -5 plus 19 is going to be 14 over 2, and so my slope is 7. So I'm supposed to show that there's the derivative is equal to 7 in that interval. Alright, so let's take a look at it. The derivative here, f prime of x, is equal to 4x to the, no, excuse me, 5x to the 4th. I got my numbers backwards here. What's going on here? My pen, all of a sudden my eraser doesn't work. 5x to the 4th plus 6x squared plus 4. So there's my derivative, and then we plug in 7. So our slope is equal to our derivative, 5x to the 4th plus 6x squared plus 4. We're going to subtract 7 on both sides. That's the thing equal to 0. 5x to the 4th plus 6x squared. And then subtracting 7, we would end up with -3. So we need to see if we can factor this guy right here. And I don't believe it's going to factor. So we would have to go to our graphing calculator and show that we can actually find where this is equal to 0. So we've got 5x to the 4th plus 6x squared minus 3. So we'll go ahead and open up our graphing calculator here. So we'll go into our Y window. I'm going to clear out these guys from yesterday. Alright, so 5x to the 4th. And then we've got plus 6x squared there we go, how's that? And then minus 3. Alright, now I could have also solved this with a quadratic formula, but I just figured this was a good one to graph. So if we graph this, what we're looking for is where does this equal 0? And so it looks to me like it's pretty symmetric here. And if you actually verified that, it would be symmetric about the y-axis. So if I can find one of these intercepts, the other one's going to be the positive value. So we're just going to go ahead and calculate. Let me see, we're looking for a 0, number 2. Alright, so we'll bring our, here we go, we need a left bound, we'll hit enter. We need a right bound, and then a guess. So it looks like it's -0.616. Alright, so we have x equals -0.616, and you can verify on your own, but the other side's x equals 0.616 positive, which are actually both in the interval. So the mean value theorem does apply on the interval from -1 to 1. Alright? And the next one says find a value of c that satisfies the mean value theorem for e to the -2x on the interval from 0 to 3. Alright, so we're going to do the same thing here. We need the slope. All right, so I'm going to start off with the slope here. This is going to equal e to the negative 2 times 3 minus e to the negative 2 times 0 all over 3 minus 0. All right, so this is going to be e to the negative 6, e to the negative 6, and then e to the 0 is 1, so this is going to be minus 1 divided by 3. So that's my slope. And so now I have to take my slope and I have to set it equal to the derivative. So let's see what we can do here. F prime of x is going to be equal to the derivative of e to the negative 2x is e to the negative 2x times the derivative of the exponent, so that's negative 2. So there's my derivative. I need to take that derivative and set it equal to this number right here. So here we go. E to the negative 6 minus 1 all over 3 equals negative 2 e to the negative 2x. First thing I'm going to do is divide out negative 2 on both sides, so I now have e to the negative 6 minus 1 all over negative 6 equals e to the negative 2x. Then I'm going to have to log both sides of this. Wow, this is getting uglier than I thought here. So we'll go ahead and log both sides. Natural log of e to the negative 6 minus 1 over, over negative 6 equals natural log. Actually, I'm going to, what happened to my eraser here? I don't know what happened to my eraser. That's weird. Okay, something's not right with my pen. Not sure what. Alright, so logging the right side, you get negative 2x ln of e. We know that ln of e is just 1. So the next thing I can do is divide by negative 2 again, but you got to be careful here because this is ln of e to the negative 6 minus 1 over negative 6. And now we want to divide that whole thing by negative 2, which is going to get ugly here. So here's what we're going to do. We're not going to divide by negative 2. We're going to multiply by negative 1/2. Because I'm just trying to see, is that even going to work? Yeah, that'll work a little bit better. So this is going to be 1/2 or negative 1/2 of ln. Now you got to remember, here's the issue. You don't want to multiply that 2 and that negative 6 because all of that is attached to the log equals x. All right. So I need to know if that falls within the interval from 0 to 3, and I have no clue. So I would take out my calculator and punch this in, and it turns out that x is approximately equal to 0.897, which does fall in the interval. So there's your value of c that satisfies the mean value theorem. All right. All right. So looking at lesson 4, I believe it is today. Yeah, lesson 4. We're going to talk about first and second derivatives. Our goal is to sketch the derivative of a function and correlate where the derivative is positive and negative to where the function is increasing and decreasing. We've done a bunch of this, but we're going to be doing a bunch more here. So it says the graph of f of x is shown. Sketch the graph of f prime of x. Well, the first thing we know is that we know wherever f prime of x has minimums or maximums, the derivative is going to be equal to 0. So that's the first thing I'm always going to do is mark my zeros for my derivative. All right. So I've got those guys all marked out here, nice and neat. And then the next thing I want to do is I want to look at where is f of x increasing and decreasing. So I know that when f is decreasing, that implies that f prime is less than 0, and I know that when f is increasing, that implies that f prime is less than 0. So we've got some decreasing, then some increasing, and I'm actually going to do this since I'm going to be doing this on another graph. This is increasing, so my derivative's got to be positive. All right, and this is increasing, so my derivative's got to be positive. All right, so I know in those two intervals I have to keep my derivative positive as I go to graph this. So I'm decreasing it first, which means my derivative is negative. then I'm increasing for just a little bit, so my derivative is positive. Then I'm decreasing from -2 to 0, which means my derivative is negative. Then I'm increasing for a while here, and my derivative is going to be positive, and then I'm decreasing after -2. So this would be f prime of x. All right? So, again, talking about the two graphs together here now, we want to look at all of these questions, okay? And so we've answered these questions before in different scenarios here. So we're going to zoom out a little bit so we can see the questions as well as the graphs. It says, give the intervals of which f of x is decreasing. Okay, so that's everything that I didn't highlight up there. So that would be -infinity all the way up to negative, what was that, -4. So -infinity to -4. And we had -2 to 0. And we had 2 to infinity. All right. Now, while I'm at it, I'm going to answer the question right below it. And hopefully this is going to make sense with what we've seen already. Give the intervals of which f prime of x is negative. Well, guess what? F prime of x, in fact, I'm going to do this. I'm going to highlight the areas where f prime of x is positive. So I'm going to highlight that. It's positive in there. And it's positive in there, isn't it? All the way down back to here. So if you look at those two intervals where I'm positive, they correspond to the intervals where f of x is increasing. So where is f prime negative? It's negative in the same intervals. It's negative from -infinity to -4. It's also negative from -2 to 0. And it's also negative from 2 to infinity. All right? So you can definitely see the correlation when you highlight the graphs and take a look at both parts. F of x is increasing from -4 to -2 and from 0 to 2. So guess what? F prime of x is positive on those exact same intervals. -4 to -2 and 0 to 2. And again, I think that's pretty obvious by the highlighting I've done on that graph that those are exactly the same. All right. What conclusions can you make from the above information? And again, we've talked about this numerous times. When f of x is increasing, f prime of x is greater than 0. Now you'll notice that I use that in terms of f of x. I saw f of x first, so I said when f of x is increasing, then f prime of x is greater than 0. Likewise, when f of x is decreasing, f prime of x is less than 0. Okay? But that rule does go both ways. If f prime of x is greater than 0, then f of x is also increasing. So if I would have seen the graph of f prime of x first, I could have worked my way backwards to f of x. Okay? And the last one says, how can you use the information above to know if a point is a max or a min? Well, here we got a little more writing on this one, but, all right? Basically, if f prime of x goes from, and I'm going to go negative to positive first, negative to positive, all right, and then I'm going to do both of them here, or positive to negative. Okay, so I'm going to talk about it in terms of negative to positive first. So if f prime of x goes from negative to positive, then f of x is going from, and so if f prime of x is negative, we're decreasing, so we're going from decreasing to increasing. Okay, that's if f prime is going from negative to positive, then we're going from decreasing to increasing. Okay, or if we're going from positive to negative, then we're going from increasing to decreasing. Okay, so f of x has a min, and again, that min is referring to decreasing to increasing, or a max, and that max is referring to increasing to decreasing. A min or a max. So if f prime of x goes from negative to positive, then f of x is going from decreasing to increasing, so f of x has a min. Okay, if f of x goes from positive to negative, then f of x is going from increasing to decreasing, so f of x has a max. Okay, so we've covered both positions there. Hopefully that makes sense, and I was just trying to save a little bit of space in the writing there. All right, so now we're going to talk about sketching second derivatives here. Second derivatives are pretty much the same thing as sketching a first derivative. So it says the graph at the right shows the function f of x, and you can see that's in black here. And the first derivative f prime of x graphed together, so f prime of x is in the blue. Okay, and again you can see where f of x is at a max or a min. So if I mark a couple of these here, let me get. Why is my eraser not working? There we go. Look at that. Okay, so I'm going to mark a couple of these spots here, so you can see where f prime is at a min, or f of x is at a min, f prime is 0. Where f of x is a max, f prime is 0. Where f of x is at a min, f prime is 0. And where f of x is at a max, f prime of x is equal to 0. So hopefully you can see the correlation between those two. Again, I think what I'm going to do here is wherever f is increasing, notice my derivative, I'm increasing there, and my derivative in there is positive. I'm increasing over here, and guess what? My derivative from here to here is positive. All right? So it says on what intervals is the graph of f of x concave up? So concave up means smiling. Now, so if we look at f of x, okay, f of x is definitely smiling in this area over here. But where does it stop smiling? Because down over here, it's starting to frown now. Okay, so there's got to be a point at which it goes from smile to frown, somewhere between -4 and -2. So I'll tell you what we're going to do. If I can ever get my eraser back, I'm not sure why it quit working on me here. Here we go. So what we're going to do is we're just going to call that point where it goes from, we're going to say that the smile happens from here over to here. We're just going to cut it off halfway. Okay, now there's other ways to find that, and we will, but so that would be concave up. So we would say that f of x is concave up from -infinity to, what is that, -1 to -3, I believe. -3. And it's also concave up, so we're looking for another smile now. So again, I'm looking at a frowny face right at the top of this this relative max on f of x, but then I'm also looking at a smile maybe from here to here. Okay, so hopefully that makes sense. It has to begin frowning at some point. So I'm going to call it -1 to 1. -1 to 1. All right. Where is it concave down? Well, we skip the interval from -3 to -1, so that would be frowning or concave down from -3 to -1. And then it looks like it's also frowning or concave down from 1 to infinity. 1 to infinity. All right. Now, on what intervals is the graph of f double prime of x positive or negative. Now, we don't even have f double prime of x. Oh, that's the first thing we were supposed to do. Missed that part. Sketch the second derivative on the graph. All right, here we go. Second derivative. All right, let's see what we got here. All right, so I have to use my first derivative to sketch my second derivative. So now I'm looking for the points where f prime is at a max or a min. All right, just like I would be if I was going from f of x to f prime. So f prime of x has a max at -3, so right here. We have a min at -1, so that's a 0 of f double prime, and a max at +1, which is going to be a 0. Look at f prime. F prime is increasing on the left side here until we get to -3. So that means that my derivative, my second derivative, should be positive. Then f prime goes to decreasing, so I'm going to be negative, and then my derivative goes to positive because f prime is increasing, and then finally f prime finishes out by decreasing. All right? And now we'll answer on what intervals is the graph of f double prime positive versus negative. So positive is pretty easy to see. Negative infinity to -3. And we're also positive from -1 to 1. Hey, wait a minute. This is starting to look a little familiar, isn't it? Where are we negative? We're negative from -3 to -1. Coincidence? And 1 to infinity? I think not. All right, I think not. So what conclusions can you make from the information above? Okay, now again, notice what we're talking about here. We're not talking about f prime and f double prime. We're talking about f of x and f double prime of x. All right, so that when they say what conclusions can you make, we're talking about f of x right here and f double prime. So we were talking about concaved up and the intervals where f double prime is positive. So if f of x is concave up, then f double prime of x is greater than 0. Okay? And if f of x is concave down, then f double prime of x is less than 0. So again, I want you to look at my red highlighted areas on f of x. Okay? So if you look at these red highlighted areas, these are the areas where f of x was smiling, concave up right here and over here on this side. Look at my graph of f double prime. I'm positive here and I'm positive here on those same intervals where I was concave up. This has nothing to do with increasing and decreasing from f of x. All right? We were able to sketch the graph of f double prime based on f prime of x. So the intervals where f is concave up, then f prime, double prime, is greater than 0. And if f of x is concave down, then f double prime is less than 0. All right? Now, take a look at your number line down here. The number line has all the data that we collected on the first derivative. All right, and I'm going to make some lines in here, and then I'm going to separate these lines. Actually, we'll stick with the green here. So f prime of x was negative, all right, from -infinity all the way up to -4. That means that f of x is decreasing on that interval. And you could go back and look at that, but these are all the intervals from the graph. F prime of x was positive from -4 to -2, so f of x was increasing on those intervals. And then f of x went back to, f prime of x went back to negative, so f of x was decreasing on that interval. And then f of x went, or excuse me, f prime of x went back to positive from 0 to 2. So f was increasing, and then f prime of x went back to negative from 2 to infinity, so f of x would be decreasing for the rest of its life. Okay? Now, if we look at f double prime of x, okay, so if you look at the graph just above here, f double prime of x, let's do a different color here. We'll do this one in, how about purple? So f double prime of x was positive all the way up to this point at -3. So if we look at this interval right here, f double prime was positive, and we said that f of x was concave up. Alright, so all we're doing is marking off intervals where these things are happening. So f double prime then went to be negative until it hit -1. So you can see that it was negative down in this little green section up top there. So f double prime was negative. And f of x was concave down. And then of course f double prime went back to positive until +1. So f double prime was positive. F of x went back to concave up, and then finally f double prime went to negative for the rest of its life, which means that f of x would be concave down for the rest of its life. Okay? So that's kind of how we can space it off and see what's going on here. Alright? Okay. So it says, on what intervals is the graph of f both increasing and concave up? Increasing and concave up. So we're looking for these intervals. Increasing, concave up. So we're talking about the graph of f. So f is here and here. Okay? So f increasing, that doesn't happen until -4 to -2. But I'm only concave up from -4 to -3. We're looking for where both of these are happening. So I would say that from -4 to -3, I'm increasing and concave up. So again, I need to be increasing. So if you go to the next interval, -3 to -2, f of x is increasing, but it's concave down. Then f of x goes to decreasing, which we don't even want. We want increasing. So then I go back and I find where f of x was increasing, and I find that it's concave up from 0 to 1. Alright? So I have two intervals where we're both increasing and concave up. -4 to -3 and 0 to 1. Okay? That's the first one. And then it says, where is f of x both decreasing and concaved down? Okay, so now we're looking for decreasing. Okay, so f of x is decreasing at first from -∞ to -4, but it's concave up. So we skip over to the next decreasing interval. We are decreasing here and concave down in this interval from -2 to -1. Alright, so we know -2 to -1 is one interval. And is there another one? Decreasing, concave up, increasing, decreasing, concave down. So from 2 to infinity, I'm decreasing and concave down. Alright? So when f changes from concave up to concave down, we call that a point of inflection. Okay? So the point where a graph goes from concave down to concave up, or concave up to concave down, is called a point of inflection. Give the x-coordinates of each point of inflection. So I need to know where f goes from concave up to concave down. Now, if you look at how I've spaced off my graph here, I have some pretty obvious pieces here, I hope. Alright, so I'm going to go with orange here. So I went from concave up to concave down right here at -3. I went from concave down to concave up at -1. And I went from concave up to concave down at +1. So let's go back and look at my graph. Now, I should already know that it should be at x equals -3, -1, and 1. But let's go back and look at the graph of f and f double prime. Look at the graph of f double prime. Look at this. -3 right here, -1 right here, and +1 right here. Go back up to the graph of f. Look at those same values on f. Now I'm going to do some erasing on f just so I can sort this out for you a little bit nicer here. Okay, so we're going to get rid of some of this stuff on f. Now, look at the same values on f. -3, -1, and +1. So that is where f changes concavity. How could I find that? How could I find these same x values from the first derivative? We'll check out the first derivative. Okay? When f changes from concave up to concave down, my first derivative is 0. Okay? My first derivative is 0. Or excuse me, my first derivative has a max. I shouldn't say 0, it has a slope of 0. That's what I meant to say. So if my first derivative has a max, then that means my second derivative has to be 0. Take a look at the next point of concavity, right here, at -1. My first derivative has a minimum, which means that my second derivative is equal to 0. And then my third point of concavity over here at +1, my first derivative has a max, which means my second derivative is 0 there as well. Okay? So how do we know? Give the x-coordinates. Okay? So the x-coordinates were x equals -3, -1, and 1. And it says, how could you find these same x values using, and it, you know what, I think I have a typo here. It says the first derivative, but this should say the second derivative. How could you find these values from the second derivative? Find where f double prime of x is equal to 0. If I know where f double prime of x is equal to 0, then I know that I have a point of inflection on the graph of f of x. Okay? F of x. All right. So hopefully that made sense. Hopefully you can see it in the chart, in the graphs right there. Let's take a look at the next page here. All right? So this is more just an informational page here. Okay? But these are all the things that we've talked about in terms of f and f prime and all that kind of stuff. There's a couple of graphs over here I want to fill in really quickly. You can read about increasing, decreasing, and constant. We've talked about those many times. So if f prime changes from negative to positive at c, then f has a relative minimum at c, f of c. So what this is basically saying, look, if f prime changes from negative to positive, what does that mean? Let's say that this is f prime and it's coming up like this, and f prime does something like that. Okay? So this is f prime. And we're going to say it's on this closed interval from here to here. All right? So if this is f prime, and this is the point x equals c, all right, then f would have a relative minimum, because that tells me if f prime goes from negative to positive, that means f of x goes from decreasing to increasing. Well, what's that going to look like? That's going to look something like this. Decreasing to increasing. Okay? Something along those lines, just like that. So I would have a minimum on f of x at the value of c. All right? If f prime of x changes from positive to negative, so let's say that f prime of x is doing something like this. There we go, and we'll close that interval from here to here. And so f prime, again, this is f prime of x, and it's going from positive to negative, so that means that f of x, all right, is going from increasing to decreasing. So I would have to have a value here, we'll call this C again. I would have to have a value C where f of x has a maximum on that same interval, okay? And then what if f prime of x does not change sign at C? So what if f prime of x does something like this? Let's say that f prime of x comes down, bounces off here, boom, comes back up, and there's my interval. Okay, so there's my interval A to B. Here's my point C. All right, so if f prime of x does not change sign at C, then f of C is neither a relative max nor a relative min. So you can't really say anything about the graph of f of x at that point. Okay, at least we won't right now. Okay, all right. The rest of that talks about concavity, just some notes and things that we've already talked about. So let's take a look at another way to look at these. All right. So it says complete the conclusion for each interval, then graph the function and label everything. Okay, so now you'll notice some of these things tell me stuff about f of x, some of them tell me stuff about f prime or f double prime. So I need to graph this based on the information that I know. So all I know is that from the interval negative infinity to negative 1, f prime is negative. Okay, well, if f prime is less than 0, that implies that f is decreasing. Okay, so I'm gonna graph in a few minutes, and we're gonna need to know that. And then if f double prime is negative, so if f double prime is less than 0, that implies that f is concave down. Okay, so those two things we're going to use to graph. Now look at the next one. They tell me when x is equal to negative 1, f of x is equal to 1/4. So they're actually giving me a coordinate right here. Negative 1, 1/4, and that's going to be some sort of a point on the graph of f of x. We'll determine that in a little bit. F prime of x is negative. So again, if f prime of x is less than 0, then that means that f, oops, forgot my little, and my eraser is not working too well here. That implies that f is still decreasing. Okay, f is decreasing. It says that f double prime is 0. So if f double prime is equal to 0, that implies that f prime has a max or a min, but I really don't care about that because my goal is to graph the function f of x. And so if f double prime is 0, that implies that f of x has a point of inflection. We're going to call it POI, a point of inflection. And that point of inflection is going to be at negative 1, 1/4. So we know that f is changing concavity at negative 1, 1/4. All right, let's keep going. F prime is still negative. So f prime is less than 0. That implies that f is still decreasing. All right, f is decreasing. F double prime goes to positive now, so f double prime is greater than 0. That implies that we did change concavity, so f is concave up, which makes sense because we have a point of inflection at negative 1 and 1/4. So a point of inflection is where we change concavity. All right. So the next one, we have another point, 0, 0. But this time it tells us that f prime is equal to 0. So f prime equal to 0, what does that imply? Well, that implies that f itself, not f prime, f has either a max or a min. It's going to be our job to determine that. Okay, and we're going to do that in just a minute. And that max or min is at 0, 0. Okay? Look at f double prime. F double prime is positive. F double prime is greater than 0. So that implies that f is still concave up. Now, let's go back and take a look at this. Can we tell if this is a max or a min yet? Well, f was decreasing above, but we don't know what it's doing below yet, so let's keep going. F prime of x is greater than 0 here. It's positive, which implies that f is increasing. F double prime is also greater than 0, which implies that f is concave up. Now, let's stop here and go back and look at that min-max. All right? So, in line 3, f went from decreasing to increasing. In line 5, if I go from decreasing to increasing, that implies, so I'm just going to make a little note here, decreasing here, increasing here, which implies that this is a min at 0, 0. Okay, so I have to look on both sides of that point where f prime is equal to 0. All right, let's keep going. What else do we have here? We have, we have another point, 1, 1/4. All right, f prime is positive, so f prime greater than 0 implies that f is increasing, and f double prime equal to 0 implies that f has a point of inflection. Point of inflection at 1, 1/4. Okay, so we have another point where we're changing concavity. Okay, and finally the last one, there's no point given, but we know that f prime is greater than 0, so that implies that f is still increasing. F is increasing. You know what? I missed my f right back here on this one. Come on. So this implied that f was increasing. This implies that f is increasing. Now my second derivative is negative, so f double prime is less than 0, which implies that f is now concave down. So we did change concavity from between at the point 1, 1/4. So we changed concavity from here to here, basically. Okay, or I should say from up here to down here. All right. So now we need to put all this stuff together, and the first thing we want to do is we want to graph the points. So I have 3 points that are key values here. We have -1 1/4, 0 0, and 1 1/4. Now you're gonna have to be patient with me because I can't scroll in and see everything, but you guys definitely can on your graph here. So I'm just going to call this 1/4. I don't really care about the scale, so I'll call this -1/4. I know that f has a point of inflection here at -1 1/4 and +1 1/4. Okay, and I know that there's a minimum at 0 0. I guess I really didn't need the -1/4, did I? Nope, didn't need the -1/4. That's okay. Now, if you look at your table, in the very first line, it says that f is decreasing and concave down from -infinity to -1. So in this entire area out here, I need to be decreasing and concave down. Okay? So guess what? Here's decreasing and concave down. Is that perfect? No. Do I care? No. All right? The second line down says we hit a point of inflection at -1 1/4. All right. That's okay. We're still fine there. The third line down says that f is still decreasing, and we're now concave up all the way until 0 0. So 0 0 is our min. So now we're concave up. So we switch concavity. Now we're concave up. We're still decreasing, still decreasing, still decreasing until 0 0. And then right in the middle of that chart up above, we change from decreasing. It says we have a min there. And we change from decreasing to increasing. Okay? So I'm gonna go back up just a little bit so you can see that. So right here, we've got our minimum here. So we've already marked our min here. And now we're here where it says f of x is increasing and concave up until we get to the point 1, 1/4. So now I'm increasing, concave up, I'm smiling. All right, close enough. Then I have a point of inflection. So I had a point of inflection over here where I change concavity. I have a point of inflection over here where I'm changing concavity. And then the very last line in the chart says f is still increasing, but now it's concave down. Still increasing, but now concave down. There's a possible graph for f. All right? That wasn't so bad, was it? You just got to organize your data and be able to read through it. Here we go. Let's take a look at another one. All right. So we're going to run through this one a little bit quicker. We know that f prime of x is negative. So f prime is less than 0. F prime less... What the heck's going on here? F prime is less than 0, which implies that f is decreasing. And for some reason, I keep losing my prime on there. I'm not sure why. What's going on there? F double prime is greater than 0. Wow, what is going on here? Which implies that f is concave up. Next line, we have x equals 1 and f of x equals 0. So we have a point at 1, 0. Not sure why all my stuff's disappearing here. Maybe my computer's getting a little tired. So we have a point at 1, 0, but the derivative is undefined, and the double derivative, f double prime, is undefined. So we'll have to see what's going on there, okay? From 1 to 3, we have f prime positive. So f prime greater than 0, good night, implies that f is increasing. So you can see from line 1 to this line, we've gone from decreasing to increasing, okay? But no talk about a minimum here or f prime being equal to 0. So it'd be interesting to see what happens there. F double prime is less than 0, which implies, good gosh, that f is concave down. F double prime implies that f is concave down. Next one, we have a point 3, 4, 3, 4, and f double prime equals 0, or excuse me, f prime is equal to 0. So that implies that f has a max or a min. We'll figure that out in a minute. All right. F double prime is negative. F double prime is less than 0, which implies that f is concave down. We go to the next one from the interval 3 to 5. F prime is negative. F prime less than 0 implies that f is decreasing. All right, and I'm going to come back to that in just a second. F double prime less than 0 implies that f is concave down still. All right, so now I'm going to hold up here, because once I see this, okay, I'm gonna go back, because I need to figure out if this is a max or a min. So I need to look at what's happening from here to here, and I went from increasing to decreasing right here. So if I go from increasing to decreasing, that means that f had to have a max, and that max is at 3, 4. All right, so we're going to use that as one of our points in just a minute here. All right, back to our chart. At x equals 5, we have another point, 5, 0, but again, the derivative and the second derivative are undefined, okay, which means the limit from the left and the right are not the same, okay? Now, it doesn't say it's 0. It says it's undefined, which means the limit is not the same. Last one, 5 to infinity. The derivative is positive, so f prime greater than 0 implies that f is increasing. F double prime greater than 0 implies that f is concave up. All right? So it also looks like we changed concavity at 5, 0 as well. So let's mark a couple more things here. So from here to here, All right, we had a change in concavity. Concavity, because we went from concave down to concave up, so this is a point of inflection here. Did we change concavity up here? Oh, look at this. We certainly did. Right here, we changed concavity. Change concavity, which means 1, 0 is a point of inflection. All right, so I'm going to be reading off the chart as I graph, so you're going to have to follow along with me on the chart. And I'm just going to talk about this in terms of line 1, line 2, line 3, line 4, line 5, 6, and 7. All right, so here we go. All right, so the first thing I'm going to do is I'm going to plot the points. So in line 2, I had the point 1, 0. In line 4, I had the point 4, 0. And in line 6, I had the point 5, 0. All right, going back up to line 1, it said that f prime was less than 0, which means f has to be decreasing. So f is decreasing, and it's concave up, so it's smiling. All right, so decreasing and concave up. Now, that could look like a whole bunch of stuff, but I'm just going to do this. Decreasing, concave up. How does that look? Decreasing, concave up, right? Now, it says this, the first and the second derivative in line 2 are undefined. Okay? And so at 1, 0, there's something going on here, so I'm going to have to go down to line 3. It says that f prime is greater than 0, so we know at 1, 0 we're going to start to increase, and we also have to be concave down. Now check it out, because we stay concave down all the way to the point 4, 0. Okay? So at the point 4, 0 we're concave down, at the point 1, 0 we're concave down. We're changing concavity here, and so at the point 3, 4, I kept saying 4, 0, I apologize. At the point 3, 4. So we'll just call this 4 right here. How's that? Close enough? So I was reading line 4 wrong. I apologize. So that's the line 3, 4. So we know there's a point up here. And so it says that we're concave down from 1 to 3 and increasing. If you look at line 3, concave down, increasing. All right? Well, here's concave down and increasing. And we determined that the point at 3, 4 was a max. Okay, so I'm at the top right there. Line 5 says from 3 to 5. Did I plot something wrong here? 3, 4. You know what? I plotted the point 4, 0, which shouldn't be there. Sorry about that, guys. All right. So at the point 5, 0, we have a derivative undefined. We have a second derivative undefined. But from 3 to 5, we're decreasing and concave down. Decreasing, concave down. So something like that. And then at 5 to infinity, all of a sudden we're increasing and concave up again. Increasing, concave up. Now hopefully that makes sense why the derivative and the second derivative are undefined, because I have a sharp turn at x equals 1 and 5. So a sharp turn at x equals 1 and 5 implies that f prime is undefined, so f double prime is undefined. All right? Whew, that was a good one today, huh? All right, let's see if I can get this thing turned off.